Okay, man, these just get a little bit hairier. I hope that you follow. If you're getting struggling with these, you need to go back and watch those other videos, all the rest of them in these lessons, and kind of build your way up to doing these, because this is going to be kind of hairy. We have to remember a lot of things that we've learned here. To begin with, let's think about this, right? We have y to the negative 5 power. So remember that a negative power means we need to inverse this, or actually we just take this and move it into the denominator. If I remember that shortcut, that would be really good. And I can take this and move it in the denominator and make that 5 a positive. So I would write that in the denominator as y to the negative 3rd power raised to the 5th power. And this is also, get a different color here, this is also a negative. So this grouped together, base is being raised to a negative power, which means I can take that and move it into the numerator and make that a positive. So I would put this whole base, which was y squared, a to the negative 3rd, and raise it to the 5th power and make that 5 now is going to be a positive because I moved it into the denominator. Okay, so let's really look and see. This is the long way to do this, but it's good so you understand what's going on. This is saying I have 5 sets of this. So I'm just going to bring that up here, man. And let me do this in green up here. I'm going to take all of this and I'm going to rewrite it as best I can. I'll try not to make it horrible, but it's y squared times a to the negative 3rd. Oh boy, sorry about that. The negative 3rd times y squared times a to the negative 3rd, right? Ooh, doesn't want to write up there at the top of my screen. Okay, but we're going to just try and remember that what this is, y squared, man, that 2 doesn't want to work, times a to the negative 3rd, and then y squared times a to the negative 3rd, that's a 3, and then the last time y squared, oh man, y squared times a to the negative 3rd. Now what I'm going to do is I'm going to use the power of commutation. I'm sorry, the power of commutations. All this is being multiplied together. I can actually use the power of association of multiplication, the associative property. That's what I really should say. Sorry. Let me get clear on this. The associative property means I can take all these multiplies, and the commutative property says I can move it over. The commutative property means to move things, right? So I can write this as y squared times y squared times y squared 5 times. So what would that look like? Y squared, right? Oh, crap. That's a 2 times, sorry my language there, y squared. And I would repeat that, y squared, right? And times y squared times y squared. Well, that's y times y. And then I'm going to repeat that 5 times, right? Y times y times, there's 1 set, 2 sets, 3 sets, 4 sets. Y times y. Hey, I've got repeated multiplication. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, look at that. That is the same thing as 2 raised to the 5th power. So this is equal to y to the 10th, right? I can think of this as y to the 10th up here. And what I can recognize is that if I take y squared and raise it to the 5th power, I could have just taken this 5 and multiplied y squared 5 times out, distribute that 5 times out, and I can actually distribute this 5 in here. So y squared to the 5th power means I'm going to have 10 y's. And here I have a to the negative 3, raise that to the 5th power, means I have 5 sets of negative 3. So that's times a to the negative 15th power. Now I just distribute this the same way, and I'd have y to the negative 15th power. Well, I don't like having negative exponents, right? I don't really want to do that. So I'm going to take this negative exponent and move it to the numerator and make it positive, and I'll take that negative exponent and move it to the denominator and make it positive. So I have y to the 10th, that was this part here, times, and I'm going to make y to the 15th over a to the 15th. All right? So how can I write this a little bit better? Well, this is 10 y's and 15 more. That's y to the 25th. Notice when I'm multiplying, I could just say, if the bases match, I can just add together how many times it's been multiplied. 10 over here and 15 more is 25 over a to the 15th. All right? Well, oh man, how can I look at that? That's y to the 25th divided by a to the 15th. That's another way to write that. But I want to show that this is in the denominator. They don't want me to write it as a fraction. So I have to put this back in the numerator if I want to make this times. Y to the 25th power times, if I move that, this is a to the 15th over 1. So I'd have to inverse it and make it 1 over a to the 15th, right? I mean, that's what this is. It's times 1 over a to the 15th. And I can rewrite that as y to the 25th, right, is equal to a to the, times a to the negative 15th. See how a to the negative 15th is the same thing as 1 over a to the 15th? So there's my answer. N would be 25, a would be negative 15. Notice it says assume that y does not equal 0 and a does not equal 0. Because if y was equal to 0, then this would turn this whole thing into 0. And we can't have the whole denominator 0. You cannot divide by 0. And a cannot be equal to 0 either. And you're going to see that if we use our CHS calculator on this, we're going to run into some trouble. Okay, it's going to get kind of ugly because the calculator doesn't know this assumption. So here we go, y to the 25th times a to the negative 15th. So let's go into here. We would go y to the 25th times a to the negative 15th power. Okay? Now, let's see what our calculator says if we write that out. Oh man, the calculator is not going to like this. I can tell you that right now. All right, what was it? Fraction. Okay, so we're going to go start by making a fraction. So let's control divide. Let's work on the numerator. Numerator is grouping symbol y to the negative third raised to the negative fifth. So y, oops, I better put my grouping symbol in here. Grouping symbol. Y to the negative third raised to the negative fifth power over y squared a to the negative third to the negative fifth power. So this is grouping y squared times a to the negative third raised to the negative fifth power. I don't know if it's going to like this because it doesn't know what y is. It might give us some instruction to say, okay, here it is as long as it's y and a aren't equal to 0. And notice the little exclamation point here. It says domain of the result might be larger than the domain of the input because you can't necessarily have the inputs. These cannot be equal to 0. That's why it's saying that. You might get more answers than there really is inputs for because you cannot put 0 in here. Okay? So we got, this simplified it quite a bit for me, and then I just have to remember that if I want a to the 15th, I've got to make this the negative 15th. Let's try one more. And I'm going to do this one. Let's see. I'll do it as fast as I can. I don't want you to spend so much time watching these, but I really think it's good for you to see a few of these before you work on all of them on your own. That is very tough to do your first time when you're working through these. So it's good to have a lot of examples is how I feel about it. Let's get this guy out of here. Okay. We'll get this garbage can down out of here. Okay, let's try this again. So I'm going to just look here and I see that I've got a negative power. I'm going to move this into the denominator because that is negative. So I'm going to go x to the negative 2 power squared. Okay. And I can distribute that, and it 2, if I have negative 2 times 2, that means I'm going to have, negative 4. So this is going to be x to the negative 4 power. That's what's in the denominator right now. And this is also going to stay in the denominator for a minute, right? So I'm going to have only 1 on the top. When I move this down, it leaves a 1 on top by itself. So that's times x to the negative third p to the fourth, and that's all raised to the second power. This group here is raised to the second power. So what's that equal to? If I distribute that 2 in here, so then that is going to go 2 times negative 3. I get x to the, this is all equal to 1 over x to the negative 4. And now I have times x to the negative 6 and times p to the 8th. I got 4 sets of them twice, right? So that's 8 total p's. Now these guys, gosh, these are combined. So, you know, if I have x to the negative 4 and x to the negative 6, that's the same thing as 1 over x to the negative 10 times p to the 8th. Another way you might look at that is just, hey, those are negative exponents, so I'm going to move them into the numerator and make them positive, right? So you could have said x to the 4th times x to the 6th over p to the 8th. That's another way to do it, p to the 8th. Or you combine them down here and you get x to the negative 10th and then say, oh, I want to move that up to the top, and you get x to the 10th over p to the 8th. Negative exponents move to the top, negative exponents move them to the bottom, make them positive. So, and here if I look at this, you know, 4x is here being multiplied times 6 more x's being multiplied, total of 10 x's being multiplied. We can add those exponents again. Those bases match, so we can add the exponents. So I end up with x to the 10th over p to the 8th. Now how do I write that as a fraction in this form without putting the p in the denominator? Well, because this is in the denominator, I'm going to move it back into the numerator, so I get x to the 10th times p, but when I move it back up here, it makes that 8 negative. So there's my good answer right there, x to the 10th times p to the negative 8th. So x to the 10th times p to the negative 8. I look here to make sure what I've typed up is what I want it to look like. Notice that arrow that I put in there. It needed to make sure that it did come out the way I wanted it to look. So check yours out there. Okay, I'm going to see if I can do this faster in the calculator now, because I do want to get through a couple more and see if there's any different types of problems here. But the calculator might be able to help me out with these. So let's try that out. Let's go into the calculator directly from here. So I'm going to have a fraction to begin with. So let's do a fraction. So control divide. And in the numerator, I have a grouping symbol. So I'm going to use my parentheses, and I'm going to put in qx to the negative 1. Now remember, if I don't put a times x in between them, it's going to assume that the qx is one variable by itself, because it can have 2-letter variables in this calculator. So I've got to put times x, right? Because we know this is just one letter and another letter being multiplied together, 2 separate letters. Okay. And the negative 1 is not grouped. The qx is not grouped together to be raised to the negative 1 power. So the negative 1 only applies to the x, all right? And then all of that is raised to the 3rd power, right? And then down here, I have another grouping symbol. So I'm going to put q to the negative 4x squared. So q to the negative 4th power times x squared, and square that. So I'm going to square that entire group together, and I hit enter. And boy, this is nice. And I get that same error message that says, hey, we might not allow inputs where x or q are equal to 0. That would 0 the denominator, which you cannot do. So q to the 11th, and to move this up in the numerator, I had x to the negative 7th. So q to the 11th, x to the negative 7th. So q to the 11th, I put a space in there, times x to the negative 7th. Was that right? Yeah. Q to the 11th, x to the negative 7th. So let's go ahead and try that out. Cool. Okay. Man, we can just continue doing these. I will do 2 more to see if they're all the same. I can do these pretty quick. So control divide. I'm going to do these two in the next minute and a half, 2 minutes. Okay, grouping symbol on top, t to the negative 3 to the negative 1. So t to the negative 3, and all of that is raised to the negative 1. That's my numerator. And my denominator is grouping symbol t to the negative 3, z to the negative 5. Grouping symbol t to the negative 3 times z to the negative 5. And then all of that gets raised to the negative 2 to the negative 2 power. And if I hit enter, aha! So the t is in the denominator and the z is in the denominator, so I'm going to have to move them both up and make both of these powers negative. So t to the negative 3, z to the negative 10. So t to the negative 3, and then I put a space, times, and then I'm going to put z to the negative 10. Was that right? T to the negative 3, z to the negative 10, yeah. All right, this is a good way to do it, man, using your calculator. Okay, here we go. Last one to get these done. Again, we are doing fractions. So in the numerator, I just have p to the negative 4th to the negative 4th, and that is over grouping symbol p to the negative 1, q to the negative 5, grouping symbol p to the negative 1, and then q to the negative 5, and that whole grouping symbol was raised to the negative 5 power. All right, negative 5 power, and I hit enter, and I know I've got p to the negative 9, q to the negative 25, so p to the negative 9 space times q to the negative, what was it? Negative 25, negative 25 power. So p to the negative 9, q to the negative 25, yep, and that works just fine. So that's how those are done, okay? And go ahead and get them done now.